In this segment, I want to talk about processor design and evolution, including covering how processors are actually made, the changes in technology that have occurred over the years, as well as changes in packaging and power consumption. Now, when most people think of a processor, they think of a chip like this, for example, this Intel Core i-series processor that I have here. Now, when most people look at this, they say, oh yeah, that's a chip, but what they're really looking at is the package. What I'm really interested in, what we're going to talk about more here, is what's inside the package. Now, in this cutaway view, I have a magnified image of one of Intel's latest Core series processors, and underneath this metal cap, you can see the actual processor die. The die is the actual circuit that comprises the processor. Now, this circuit is incredibly complicated. These circuits can have upwards of 1 billion or more transistors in them. So it's an incredibly complicated circuit. In fact, I would have to say the processor is one of the most complicated components that is manufactured by man today. So let's look at how these things are actually made. Well, processors, the raw material that go into processors is silicon. And I have an example of a chunk of pure silicon right here. Now, silicon is the second most abundant element on the planet. The only thing that we have more of is oxygen. One thing, though, silicon is rarely found in any kind of a pure form. It's mostly mixed with oxygen in the form of silicon dioxide, which most of us know as quartz or sand. So, in fact, sand is mostly silicon. So, many times you've probably heard that, electronic circuits are made out of sand, and that's largely true. So what happens is we take the sand, melt it down, and put it through a purification process until we extract the 99.999% pure silicon. Now, even that's still not ready to make chips out of. We need the silicon not only to be pure, but to be in the form of a crystal. So what happens then is the silicon, the pure silicon, is melted in a vat, and a seed crystal, like the one I have here, is dunked into the vat of molten material. It's slowly turned and then pulled out. Now, if you imagine this vat of molten material, it's kind of like melted glass. It's sort of thick and taffy-like. And as the crystal begins to pull out, some of the material sticks to it and begins to harden. So what happens is this seed crystal pulls out of the vat, and you can see a bunch of material sticking to it. And they pull at first rapidly until we have a very thin stem forming, and then finally more slowly until a wider and wider crystal begins to emerge from the vat. This is an example of a pure silicon crystal that I have here that was grown in one of these vats. As you can see, the shoulder of the crystal gets wider and wider as it is pulled out. This is like millimeters per hour. It's a very slow process. Now, once the crystal reaches the diameter that is intended to be, then the process speeds up a little bit. It's pulled out a little bit more quickly until basically what we have is like a cylinder. Imagine a cylinder of this crystal material being pulled out of this vat. Once the cylinder has reached its final length, which is usually a couple of feet long, then the pulling process goes more quickly and we end up with a tail. They want to actually have a sort of a gradual pull out of the material from the vat to prevent any kind of thermal shock. Now, the tail on this crystal is very short. It's very short here, as you can see. In fact, this was an aborted crystal process. Normally the main body would be not just an inch here, but would be several feet tall. This, in fact, is here as an example of a tail of a more complete crystal. So if you can imagine, this thing was several feet tall, and then this was the tail that's basically cut off and is considered waste. The head and the tail are then chopped off of this crystal. So now what we have is this cylindrical crystal of silicon. Head and tail are cut off. This is then put into, it's ground so that it's perfectly round, and then it is put into a saw that cuts it into thousands of plates called wafers. I have an example here of a wafer that was cut from one of these crystals. You can see that it's, it's round and is very thin. It's